Good morning to all of you. I'm Dr. Neetu Gehlot, working as an assistant professor in St. Andrews Institute of Technology and Management, Gurgaon. I'm from the Applied Science Department, and my subject is chemistry. And today we are going to discuss that topic that are the flame photometry. Okay, so this is my 28th lecture, and then come to the topic. So now the topic of my lecture is the flame photometry, and as we know that we are discussing about the spectroscopic method, and here in the spectroscopy technique we have already discussed the basic information of spectroscopy, then ultraviolet spectroscopy, then infrared spectroscopy, and uh, then we already discussed the NMR spectroscopy also. And now we are discussing about the flame photometry. So that is another topic which is related to the spectroscopy method. So firstly, as the name is suggested that here is the flame is necessary. Okay, so it is the flame photometry. And this is the type of the emission spectroscopy, and it is termed as the flame emission spectroscopy. So for the discussing the introduction of the flame photometry, so here we know that the flame photometry that the more is the actually it is called the flame atomic emission spectroscopy. Okay, and actually the flame photometry is called the flame atomic emission spectroscopy. That is the we know that is the branch of spectroscopy in which the species examined in the spectrometer are in the form of atoms. Okay, so here the introduction of the flame photometry, and a photoelectric flame photometer is the instrument that is used in inorganic chemical analysis to determine the concentration of certain metal ions, among them sodium, potassium, calcium, and the lithium. Okay, it means these are the for the S block elements. Okay, and the flame photometry is based on measurement of intensity of the light emitted when a metal is introduced into flame. So here the wavelength of color that tells what the element is. So that is the qualitative, and the color intensity tells us how much the element present, so that is the quantitative. Okay, it gives the information of the element as well as the qualitative and the quantitative also. Okay, so now that is the flame photometry, and here the principle of we are talking about the principle of the flame photometry. So here the principle of the flame photometry at which the flame photometer work. So the basic principle upon which atomic spectroscopy work is based on the fact that the matter absorbs light at the same wavelength at which it emits light. Okay, so as we discussed in the spectroscopy, so there are we have discussed that there are the radiation is present here, or we can say that there are the EMR, yani electromagnetic radiations, by which uh, electron gets excited and they reach to the higher energy level from the lower ground energies level. But here, because the electron is excited in the presence of the flame. Okay, and as we see that the first S block element, these are the sodium, potassium. So they have the one electron in its outermost cell, so that this electron easily excited with the help of the some energy, so that it excited and it goes to the higher energy level. And after that, when it comes to the with the there is a emission. Okay, So after the emission of the energy, so it comes into the, again it will come into the ground level. So this emission spectra, this emission spectroscopy, that is a flame emission spectroscopy. Okay, so here we are talking about the principle when the certain metallic salt solution is spread into a flame, so the solvent get evaporated and the sum of the salts undergo dissociation and forms constituent atom is vapor state. Okay, some atom get excited by absorbing thermal energy and the electrons get promoted from lower energy level to the higher energy level. Clear? Okay. By the vapor state, so that there is the absorption of the thermal energy and the electron get excited and they promote from the lower energy level to the higher energy level. So when these electrons return to the ground energy level, एक बार जब वो ऊपर एक्साइटेड स्टेट में चले गए, तो आफ्टर दैट देयर इज द एमिशन टेक्स प्लेस एंड सो दैट द इलेक्ट्रॉन्स return to the lower energy level, so they radiate energy of different wavelength. Clear? So this radiative energy on passing through optical filter emitted and characteristic wavelength radiation, which is amplified and recorded by a suitable digital readout system. It means कि जब वो वापस emission के थ्रू अपना ग्राउंड लेवल एनर्जी लेवल में वापस आ चुके हैं, तो it means there are the different wavelength present, है ना? So and the different wavelength they shows the different color, so that we can detect or record the suitable digital read. So here this is the method, and here is the atoms, or we can say in the in short that the atoms of elements. Okay, firstly subjected to hot flame. Clear? And then the specific quantum of thermal energy absorbed by the orbital electron, right? And then that becomes unstable at high energy level. Clear? So that release energy as the photons or particular wavelength and change back to the ground state. So this is the in the short the explanation. Here, when a metal salt solution, when the metal salt solution is burned, so the metal provide a color flame, as we discussed here. You know, the metal provide a colored flame, and each metal ion give a different color flame because they have the different wavelength. So the flame test therefore can be used to test for the absence or presence of a metal ion. Okay, so now come to the instrumentation and there is a working process. Here is the one the simple or basic concept क्या है इसका, that the electron get excited and they goes to the excited state, and after the they emit the energy and then they return to its ground state. So here the liquid sample containing metal salt solution is introduced into the flame. Clear? Then the solvent is firstly vaporized, leaving particles of solid salt, which is then vaporized into gaseous state. Okay, the gaseous molecule dissociate to give neutral atom, which can be excited by thermal energy of the flame. ये इसका है सारा हमारा, that is the basic concept. Okay, so that the unstable excited atoms emit photons while the returning to the lower energy state. We have discussed these points in here, and the measurement of emitted photons forms the basis of flame photometry. Clear? So these are the basic information, basic principle. So now the come to the instrumentation and the work. So here it is the block diagram it is very essential component of the flame photometer, and we can represent this as the here. So here we can see that there is the, firstly we can see there is the solution of the metal. Okay, suppose it is a sodium chloride solution or copper sulfate solution, it was the solution of the metal compound. So then here is the nebulizer. Okay, then the metal solution is goes to the mixing chamber. Then after that it comes in the contact with the flame and the excited electrons here also, so that we can detect the color of the metal and or check the wavelength, so that we can find here is the lens, there is the filter, there is the photo cell, then the detector, and then the amplifier, and after that is the readout. Okay, so here is the process. At a particular pressure, the air is introduced into a atomizer to produce the suction of the sample solution under the examination. Then the solution of sample combined with air stream in the form of fine mist is then mixed with the fuel gas in the mixing chamber. Okay, and then there is the gases mixture. So now in the gases mixture there are the air plus sample solution plus the fuel gas. So is entered in a burner after sample introduction. The process involved is dissolution. Dissolution means there is a loss of solvent by the droplet. Okay, तो वो किस फॉर्म में आ जाएगा, वो हमारा ड्रॉपलेट की फॉर्म में आ जाएगा. Followed by dissociation of the tiny solid particles to yield analyte atom. Clear? The friction of the atoms acquire sufficient energy by collision with molecule of the hot flame gases to become electronically excited. When the excited atoms revert to lower electronic energy level, emission of radiant energy takes place. The radiation are allowed to pass through a conversing lens, optical filter, photocell, and a detector. The optical filter that permits the passage of characteristic radiation of the element under examination. Okay, so this is the process. So finally it is amplified and read out by a digital recorder. Okay, so this is the process of the flame photometry. Clear? So now this is the work of is there the instrument and the procedure of the flame photometer. Okay, and before the instrumentation and the working, we have already discussing about the principle. So here in the flow photometry, I want to explain the one more time, that is the principle. If when a solution is aspirated into a lower temperature flame in an aerosol, so each droplet of the water evaporate, leaving a solid core of the residual of evaporation. So the core further break down to the molecular level and provide the molecules are not too refractory progress to form atomic species. The atom then is excited by a flame and its electron temporarily moves to a higher energy state, and when the electrons returns to the ground state, they lose the excitation energy and a discrete wavelength of visible light is emitted. The emitted light can be isolated from other light wavelength by the optical filter. So the amount of light being emitted is proportional to the number of atoms in the flame and is follows the concentration of that atom in the original solution. Okay, and the amount of light emitted can be measured by the, here is the photodetector, and the photodetector generate an electrical signal which is amplified and display on the digital readout. Okay, and then now, so we can see that the various metal emit a characteristic color of the light when it is heated. So here, after the instrumentation and the working or the principle of the flame photometry, there is the application. And before the application, I want to tell you that some more point that if we see that suppose the sodium element is present here, and the wavelength of the after the emission, that it is called the emission wavelength in the nanometer, that is 589. Okay, so that the flame color is the yellow. Clear? For the sodium. So for the sodium element, emission wavelength is 589 and the color of the flame is yellow. And suppose we take the potassium here. So that the potassium, for the potassium, the emission wavelength is 766 and the flame color is violet. Then the barium, there is the 544 is the emission wavelength and the color of the flame is the lime green. Lime green. Then if we take the example of the calcium, so that here is the wavelength of the, it is called the emission wavelength of for the calcium, that is 662 and the flame color is the orange. And now one more example we can take here, that is the lithium. So here is the emission wavelength is 670 and the color of the flame, that is red color. So by this method we can identify or we can take the information about the elements with the help of their wavelength and the color of the flame. So now come to the applications of the flame photometry. So here it is used for the analysis of sodium, potassium, calcium, copper, etc. in the different compounds. Okay, and in industries it is useful for the detection of element in cement, glass, fuel, etc. The third, in medical science it is used for analyzing the blood and the urine, etc. And fourth, in agriculture field it is useful for analysis of solid soil, water and plant material. Okay, so these are the applications of the flame photometry. Here, one point is also that is the requirement of the flame. Okay, तो flame हमारी किस type की होनी चाहिए इस process में? So flame, it should have a proper temperature. The temperature should remain constant throughout the operation, and there should not be any fluctuation during the burning. And the functions क्या हैं flame के? So these are the functions to convert the analyte of the liquid sample into vapor state. Clear? Then come to the second point, to decompose the analyte into atoms and sample molecule. Okay, and one more point, to excite the formed atoms, free atoms, sample molecules to emit radiant energy. Okay, so these are the function of the flame. Now come to the drawbacks of the flame photometry. Here, this technique is not applicable for the analysis of all metals. Okay, so the metal which have tendency to incomplete vaporization cannot be analyzed because the information of excited atoms cannot be easily detected by the photocell. So this is the flame photometry topic. Okay, so now it is a very short topic and but it is very important. And one more thing, that is the principle of the flame photometry is very important by the uh, exam point of view. So you should prepare the flame photometry topic also. Okay, for doubt or query can contact me. Thank you.